Imagine a world without the internet. No emails, no online shopping, no streaming your favorite shows. It's hard to picture, right? But have you ever stopped to think about how this invincible web connects billions of devices around the world? Today, we are going to uncover the magic behind it: computer networking and the internet. We will explore what networks are. Let's break it down with an example. When you send a document from your laptop to the printer wirelessly, there's a network at work. It allows the laptop and printer to exchange data without needing a physical connection. Similarly, think about your smartphone. It connects to your Wi-Fi network to access the internet or share files with your laptop. This connection happens because the devices are part of a local network where they talk to each other using predefined protocols. These interactions are happening constantly, even though we might not see them. Now, take this concept beyond just your home. Picture a company with multiple departments. Employees in different rooms can share files and communicate because their computers are connected to the same network. Even security systems, like a checkpoint at the entrance of a building, use networking to connect surveillance cameras, access control systems, and central monitoring stations. These networks ensure that data flows smoothly and securely, enabling better decision making and faster response. First, it allows us to share data and resources efficiently. It also enables collaboration. Teams across different locations can work together in real time, accessing shared resources like databases and project files. Finally, networking helps enhance efficiency and productivity. By connecting devices, people can save time, reduce costs, and make tasks more streamlined. Local Area Network, or LAN. A LAN is a network that operates within a small area, like your home, office, or school. It's ideal for connecting devices in close proximity. For example, in an office, a LAN allows employees to share files, printers, and internet access. Similarly, at home, your Wi-Fi router creates a LAN that connects your devices to each other and to the internet. Wide Area Network, or WAN. A WAN, as the name suggests, covers much larger geographical areas. Think cities, countries, or even the entire globe. The internet is the most prominent example of a WAN, connecting billions of devices and smaller networks worldwide. Metropolitan Area Network, or MAN. A MAN is larger than a LAN but smaller than a WAN. Typically, covers a city or large campus, such as the university network that links multiple buildings. Device connection. Everything starts with your device, a laptop, smartphone, or tablet, connecting to the internet through an internet service provider, or ISP. The ISP acts as your gateway to the internet, providing the infrastructure that links your device to the wider network. IP addresses. Every device on the internet has a unique identifier called an IP address. This address ensures that data sent across the network knows exactly where to go. DNS, or Domain Name System. When you type a website name like www.google.com into your browser, your device doesn't understand the name directly. It needs to find the corresponding IP address. This is where the Domain Name System, or DNS, comes in. The DNS acts like a phone book for the internet, translating human-readable domain names into machine-readable IP addresses. Data flow. Once the DNS resolves the domain name, your device sends a request to the website server. The request travels through a series of routers, that is, devices that direct data across networks, taking the fastest path available. The website server then processes your request and sends data, like a web page or video, back to your device. This process happens in both directions and takes just milliseconds. Practical demonstration using the command prompt. Using the ipconfig command, the ipconfig command is a simple tool that shows your device's network configuration. For example, by opening the command prompt on Windows and typing ipconfig command, you can see details like your IP address, subnet mask, and default gateway. Using the ping command. Next, the ping command is used to test connectivity between your device and another device or server. Reply from 142.250.74.14. This shows the IP address of Google's server or whatever website you are pinging. It's proof that your computer was able to reach the server successfully. Bytes equals 32. This shows the size of the data packet that was sent. 32 bytes is the default size for ping. Time equals 106 ms. This is the time it took for your data packet to travel from your computer to Google's server and back again. Milliseconds. Ms means thousandths of a second. So 15 ms is very fast, a good internet connection. TTL equals 112. TTL stands for time to live. It's a value that shows how many hops or stops the packets can make between routers on the way to its destination before it's discarded. Latency time equals 15 ms. The time equals 15 ms part tells you how fast your connection is. Lower times are better. Below 20 ms, excellent connection, common for nearby servers. To wrap things up, let's review the key points we've covered today. 1. Computer networks connect devices to share resources. 2. The three main types of networks are LAN, WAN, and MAN. 3. The internet relies on ISPs, IP addresses, DNS, and routers to transfer data efficiently. 4. Practical tools like ipconfig and ping help monitor and troubleshoot networks efficiently. Thank you for joining me on this journey through computer networking and the internet. If you have any questions, feel free to ask. I'd be happy to answer them. Thank you.